Hey friends, my name is C, and today we'll look into 5.3 for adding and subtracting volumes for the rules and examples video for Edexcel A-Level Further Math Core Pure 1 module. So we'll start off with the volumes of cylinder and cones. So in some questions, you might need to solve volume of revolution problems involving the volumes of cylinder and cones. So here are the two volumes, and the cylinder of height h and radius r has volume pi r squared h. And the cone of height h and base radius r, which is basically the same thing, has volume 1/3 times pi r squared h. So these volumes or these equations might look familiar because we've dealt with this in IGCSE, GCSE, or A-level mathematics. So the key difference is that for the cone, there's a third attached to it, a constant a third, but for the cylinder, it's just pi r squared h. So here's a nice representation of how these volumes need to be used. So if we have just a plane, like a rectangle plane right here, if we were to rotate it 360 degrees around an axis, let's say the middle axis right here, you will form a cylinder with the radius of, let's say, r and the height of h. So to know or to figure out when to use these volumes is that you need to spot the questions and what volumes you need to find. So for example, if you have in the question you're given a graph, or if you're just given a line like this, and if the question were to ask to find the volume generated if you were to rotate this line 2 pi radians or 360 degrees around the y-axis, and if you have to find the volume, you can spot that if you were to rotate this line 2 pi radians around the x-axis, it's a bit hard to represent here, but if you were to rotate it 360 degrees around, like in this case, you will actually form a cone, right? Because instead of this plane right here, it would be like a triangle, and you would form a cone. So therefore, in this case, you would use the cone formula, where this distance here is basically the radius, and this distance here it's the height. So if it were to be 3 and 5, the volume generated, would be, let me just write it properly, 5. The volume generated would be volume equals a third pi r squared, 3 squared, times by h, which is 5, which you can simplify it to its simplest form. So we'll now look into some examples for adding and subtracting volumes. So here's the first question. The region R is bounded by the curve with equation y equals x cubed plus 2 and the line y equals 5 minus 2x and the x and y axis. Given that the coordinate of A is 1, 3, so this right here is 1 and this point right here is 3. Find the volume of solid generated by rotating the region 360 degrees around the x-axis. So we know that this region right here will rotate around the x-axis. So the first thing we should do is that we need to see what we can split, right? So this graph right here, we can see that if we were to split it down here, here, where this point right here it's 1. So down here, this point is 1. You can see that it's actually a cone rotated around the x-axis, and this volume right here, this shape. So this is actually two shapes where one is a cone and one is a shape that I mentioned. So we can just do volume. Let's split into two different volumes so it's easy to find them first. So the volume of the cone, let's call this A, and volume A, and then volume B. So let's just find B because it's easier first. So volume of B is equal to a third pi r squared h. So a third pi. So the radius of this, the radius of this cone would be 3 because it's basically this is a radius because we rotated in the x-axis. So this would be the radius, right? So pi r squared, r is 3, so pi times 3 squared times by the height. So the height is basically from this point right here to this point here. And I realize that we need to find what this point is, so we can just find it now. So this point right here is basically when this line when y equals 0, right? So solving y equals 0, 0 equals 5 minus 2x, we get x equals 5/2. So this point right here is 5/2, right? So the height is just 5 over 2 minus 1. So let me just put into my calculator. A third times pi times 3 squared times 5 over 2 minus 1. That gets us a volume of 9 over 2 pi. So it'll be 9 over 2 pi units cubed, but we'll just ignore that at first. So 0.1, or the volume. So the volume of A will be equal to pi times the integral of y squared. So we know y is x cubed plus 2, which is basically this line right here. To find the volume under it, we need to square the function and times it by pi, and as well as adding the bounds, right? Or the limits. So we have y cubed, which is x cubed plus 2 squared dx from x equals 1 to x equals, from x equals 0 to x equals 1. This gets us pi times the integral of x to the power 6 plus 4x cubed plus 4x cubed plus 4 dx from x equals 1 to x equals 0 to x equals 1. So this gets us the pi times the integral, or like times, after integrating it, you get 1 over 7 x to the power 7 plus x to the power 4 plus 4x 1 0. So we would have to substitute 1 and 0 into each term. But notice that if you just substitute 0 into each term, it basically cancel out. So we can just basically ignore this case and just substitute 1. So it will be pi times 1 over 7 times 1 to the power 7 plus 1 to the power 4 plus 4 times 1, and that gets us 36 over 7 pi. The 7 pi. Right? So the total volume, volume total will be basically equal to volume A plus volume B, which is equal to, we found just now, 36 over 7 pi plus 9 over 2 pi. And putting that into a calculator, you get a value of 135 pi over 14. So 135 pi over 14. And they didn't give you any units, so just put unit cube like so. And yeah, let's move on to the next question. The diagram shows the region R bounded by the curve with equations y equals root x and y equals 1 over 8x, and the line x equals 1. The region is rotated through 360 degrees around the x-axis. Find the exact volume of the solid generated. So in this case, we can't seem to form a cylinder or a cone, because if we were to split it in any way, we can't really do that because there are no straight lines. So what we can do is that we can first find the intersection between the two curves. So we will find this point right here, find the x value, then we can find the volume under the volume generated by this red curve right here, and the volume generated by this black curve right here, and basically subtract them. But first, let's find the intersection point. So root x equals 1 over 8x. Square both sides to get x squared. Sorry, just x equals 1 over 64 x squared. So it'll be x cubed equals 1 over 64, and therefore x equals 1 over 4. 1 over 4. So that's 1 over 4. So that means this point right here is 1 over 4. Right? So let me just rub this out. So now we can find the area, sorry, the volume, not the area. The volume under the black curve first. So the volume under the black curve, I just use V black to represent it. So V black equals pi times the integral of y squared, which is equal to 1 over 64 x squared, or 1 over 64 x squared, or 1 over 64 x squared dx from x equals 1 over 4 to x equals 1. So 1 over 4 and 1. This gets us pi times, what we can do first is that we can just take out the 64. So pi over 64 times the integral of 1 over 4, 1 over x squared dx. And now we can just use the reverse chain rule, where we know that this is basically x to the power of minus 2, and plus, how you integrate x to the power minus 2 is that you can just plus 1 to the power and divide by the new power. So it'll be equal to pi over 64 times, not times, but the integral, which is minus 1 over x from 1 over 4 to 1. And if you put into a calculator, you get pi times 64 times by minus 1 over 1 minus 1 over 1 over 4. And that gets us 0.14726. But we need to find exact volume. So what I do is that I basically just ignore the pi first in my calculator, just don't type the pi. So it's just 1 over 64 times minus 1 over 1 minus 1 over 1 over 4. And that gets us 3 over 64. And just like slap a pi onto it, it'll be 3 pi over 64. That's number 1. So for the volume under the black curve, the red curve, so V red will be equal to pi times the integral of 1 over 4, 1 over 4, 1, and y squared, which is basically x dx equals pi times, not the integral, pi times the integral of 1 over 2 x squared from x equals 1 to x equals 1 over 4. 1 over 4. So now just as well, just put into a calculator. So pi times 1 over 2 times 1 squared minus 1 over 2 times 1 over 4 squared, and that gets us 15 over 32 pi. So 15 over 32 pi, number 2. So the volume, the exact volume of the solid generated will be equal to, so the volume of R will be equal to the volume of the red curve, under the red curve, minus the volume under the black curve. So it will be equal to 15 over 32 pi minus 3 pi over 64. And if you were to simplify it, you would just times the top and bottom by 2, and 30 pi over 64 pi, 30 pi over 64 minus 3 pi over 64, which gets us 27 pi over 64 units cubed. And that's the final answer. And that's it for this video for 5.3 for adding and subtracting problems for the rules and examples video. Check out my website in the description for all the lesson slides and any other content. And don't forget to leave a like, subscribe, and ring the notification bell so you don't miss out on any future videos. And in our next video, we'll look into 5.3 for adding and subtracting problems for the questions video, which will all be questions, which will refine your skills and knowledge to practice this whole subtopic. But anyways, that's it for this video, and I'll see you all in the next video. Until then, stay safe and happy learning.